in this example, we want to add negative 9 over 25x squared minus 1 to 7 plus 1 minus 25x squared. And before we dive too deep into this and start factoring things and coming up with this extremely long LCD, right, because we always need to find the least common denominator first with these kinds of exercises, here's a little trick. When the denominators look very similar, see how these look similar? Try factoring out a negative 1 to make them the same out of one of them, right? So these look similar. Let's see. Let's factor a negative 1 out of the second one here. If I were to do that, I'm just going to factor a negative. Okay, so when you factor a negative, that changes the sign of everything left behind. So we're left with a negative 1 plus 25x squared. And now notice what happens. Look, we have 25x squared minus 1, negative 1 plus 25x squared. These are the same. So by doing that, we really shave off a lot of time that would otherwise be spent finding a long least common denominator. Okay, so let's rewrite this thing. So the first term stays the same, negative 9 over 25x squared minus 1. And now we have a minus. I'm just going to bring this minus up there, minus 7 over same denominator, 25x squared minus 1. And now we're good to go with the same denominator. So here we go, 25x squared minus 1 on the bottom, negative 9 minus 7, so that's minus 16 up top, which we can just write as negative, bring that negative to the front, negative 16 over 25x squared, oops, 25x squared minus 1. There we go. Let's try the next one. We have 7 over 2x minus 3, all of that minus 3. And when you're missing a denominator, there's really still a denominator there. It just happens to be 1, right? Any number, any variable, anything at all can be written as that thing divided by 1. So when you have no denominator, just go ahead and add in 1 for your denominator, right? Then we can still find the LCD, right? We start with the first denominator, 2x minus 3, and then we ask, what do we need to add to make sure we include the second denominator? Well, 1, but multiplying it by 1 doesn't really do anything. So we don't need to really do that step here. Our LCD is simply 2x minus 3. All right, our first denominator is good to go. Our second one needs some work, so let's multiply there by 2x minus 3. But you always do it on both the numerator and the denominator, 2x minus 3, because we're really just multiplying by 1. And let's see what happens here. So now we have our nice denominator, 2x minus 3 down below, and up above we have 7 minus 3 times the quantity, 2x minus 3. And you may want to cancel here, right? Some piece of you may be saying, oh, look, I can cancel these, and what I'm doing is wrong, so don't do it. You can't do that, because remember, if you have a negative that's not in a parentheses, even if we put all that inside a parentheses, we'd still have this negative that's not in a parentheses, and when you have a minus that's not in a parentheses, the general rule says you don't cancel if you have that. All right, so let's not cancel there because we can't. Instead, what do? We take this negative 3 and distribute it through to both those terms. Okay, so let's do that. So we have 7 minus 6x plus 9 all over 2x minus 3, and that gives us 16 minus 6x all over 2x minus 3. Okay, and again, we can't cancel the 2 and the 6 or something like that, or the 6 and the 3, because these minuses are not in parentheses. And when you have these rational expressions like that, the general rule says only cancel when all the pluses or minuses are inside parentheses. Here they are not. So we can't cancel now. Maybe we could factor something out and cancel it. Turns out we can't. That's our final answer. Just to show you though, if we factored a 2 out of this thing, we'd have 8 minus 3x over 2x minus 3, still nothing to cancel. These terms don't cancel here. So you could also have that as your answer. Let's try another one. Here we have 5 over x plus 1 times x plus 5 minus 2 over x plus 5 squared. Let's start with our LCD here. So for our LCD, we just start with the first denominator. Okay, we have x plus 1 and x plus 5. Right? Then we move to the second one and we say, what do we have to add into this denominator to make sure we include everything in the second denominator? Well, this has x plus 5 squared, so I'm going to add in I'm going to make that an x plus 5 squared. Now we include everything that's in the first and the second denominator. So that's our LCD. Okay, well, now what are we missing? In this second denominator, we have the x plus 5 squared, but we're missing an x plus 1. So I'm going to add that in as x plus 1 over x plus 1, because I'm just multiplying by 1. This one on the left here, we have x plus 1 and x plus 5, but we need x plus 5 squared. So I'm going to add in x plus 5 over x plus 5. Again, that's just multiplying by 1, so we can do that. All right, what does that give us? So I'm going to go down here with it. So now we have a nice denominator. We know what that's going to be because it's our LCD. X plus 1 over x plus 5 squared. Up top, we have 5 times x plus 5 and minus 2 times x plus 1. Okay, and this is problematic here, right? You wouldn't want to cancel anything between the top and the bottom because we have a minus that is not in parentheses. That's what we're concerned about. So let's go ahead and distribute the 5 through and the 2 through. Okay, so that gives us 5x plus 25 minus 2x minus 2 all over x plus 1, x plus 5 squared. X plus 5 squared, lots of denominators in these. Okay, now let's simplify the top here. 5x, combining like terms, 5x minus 2x is 3x, 25 minus 2 is plus 23, all over that same denominator, x plus 1 times x plus 5 squared. Oops. 5 squared. And there's no further simplification, so that's going to be our answer to that one.